Alright guys, I must admit I'm a little bit excited because this is officially the last video of this semester for A&P 1. We're going to be looking at Objective 6 through 9 in Chapter 15. And this one's going to be about adrenergic and cholinergic neurons as well as receptors. And so it may sound kind of crazy and seem kind of hard, but once you kind of break the words down, it's actually not too bad at all. So we do need to talk a little bit about neurotransmitters. This should just be a review. So we learned about neurotransmitters when we covered synapses between neurons in the nervous system. We've also seen neurotransmitters when we looked at muscle contraction, so this should not be new to us. But neurotransmitters are chemical signals that are released into the synapse. So that could be between two neurons, or that could be between a neuron and an effector cell like a muscle. Now, when it comes to our sympathetic and our parasympathetic nervous systems, they're either going to secrete acetylcholine or they are going to secrete norepinephrine. It could also be epinephrine. Pretty much anytime you see this one, epinephrine is interchangeable with it, okay? I also want to remind you that I mentioned in the last video that epinephrine and norepinephrine are the same thing as adrenaline and noradrenaline. It just depends on where you are, but they are technically the same chemical. All right, so now let's take a look at these new funky terms. We have cholinergic, okay, and I want to point out here that we've got choline, and then we have adrenergic, and I want to point out here that we have the adren, okay? So cholinergic neurons secrete acetylcholine, and so you can see the similarities there, and that's where that comes from. Now adrenergic, notice it says norepinephrine, but like I mentioned earlier, another name for epinephrine is adrenaline, and another name for norepinephrine is noradrenaline. So this is just using that adrenaline word rather than the epinephrine. Okay, so cholinergic, secrete acetylcholine. Adrenergic, secrete norepinephrine or epinephrine. Now, in terms of this right here, I know this can seem kind of confusing because we have pre and post ganglionic, and those are big words, but these are the specific neurons that are going to be considered cholinergic neurons. So here you have preganglionic sympathetic and preganglionic parasympathetic. So you can see that all of your preganglionic neurons are going to be cholinergic. Okay, all of your preganglionic neurons are going to be releasing acetylcholine. And then postganglionic parasympathetic can also secrete acetylcholine, whereas most postganglionic sympathetic neurons are going to be secreting norepinephrine or adrenaline, noradrenaline. And so I just want you to think about it for just a second. So sympathetic was fight or flight, right? And so your fight or flight is when you get that adrenaline pumping, okay? When you're responding to stress is when you have adrenaline flowing through your vessels. And so remember that norepinephrine and epinephrine are the same as adrenaline and noradrenaline. So essentially it's the same effect. So your adrenergic neurons are going to help us in that response to stress. And so as you can see, that's why it's sympathetic there. All right, now receptors for neurotransmitters, and I just want to kind of clarify a little bit. When it's talking about receptors, we are talking about protein receptors in the cell membrane, okay? Now, back when we covered the nervous system, we talked about different types of proteins and protein channels and things like that. Well, proteins are always going to be specific about what they do. They're always going to have specific locations for specific molecules. All of our proteins are specialized to do certain jobs. It's because they have a very specific and certain shape. And so when we're talking about these receptors, we're talking about protein receptors that are in the cell membrane. And what they're going to be doing is they're going to be receiving a message by attaching to a chemical, okay? Now in this case, they're receiving the messages from our neurotransmitters, okay? So these are going to be the proteins that the neurotransmitters bind to on the postsynaptic cell. So the neurotransmitters will get released into the synapse, they're going to travel across the synapse, they're going to diffuse, and then they're going to bind to a receptor on the postsynaptic cell. And so this is what we're talking about here. We're talking about what are the protein receptors that these neurotransmitters bind to. And once again, we have two types. We have cholinergic, and once again, it's no shock that it's going to bind acetylcholine. We also have adrenergic, and once again, it's going to bind norepinephrine or noradrenaline. So very similar to the neurons. Whatever the neurons secrete, then the receptors are going to be binding to that same neurotransmitter. And so here we can see up here in the somatic nervous system, remember this is our voluntary, they have one neuron, so there's my cell body, there's my axon, you can see that they're secreting acetylcholine, okay? Now, that means this is going to be a cholinergic receptor, okay? Now here we have our sympathetic, they're the ones that go to the chain ganglia, there's acetylcholine, so this is going to be a cholinergic receptor. Then you have the cell body and the axon. There's norepinephrine. So these are going to be adrenergic. Okay, and as we saw earlier, it's the postganglionic sympathetic. They're the ones that secrete norepinephrine. Okay, so these are going to be your adrenergic neurons, and this is going to be my adrenergic receptors. Here in the parasympathetic, there's my cell body. Okay, it's going to meet up with the terminal ganglia there. Once again, acetylcholine. So all of my preganglionic are secreting acetylcholine, so they're going to be cholinergic neurons. Here, this is going to be a cholinergic receptor. And then once again, we have acetylcholine. This is also going to be a cholinergic receptor. Okay. So before we get into the receptors in a little bit more detail, just know that when we're talking about chemicals, they can be agonists that cause an action, or they can be antagonists which prevent an action. So, these neurotransmitters can be excitatory or inhibitory. And when we introduce drugs into our body, and I'm not talking about just illegal drugs, but it could also be prescription drugs, but those drugs are going to enter into these communication pathways, and they can either cause something to happen or they can prevent something from happening. And the reason we bring that up is because when it comes to your cholinergic receptors, we have two types. We have nicotinic and muscarinic. Now, both of these are chemical compounds. Now, these receptors are cholinergic, which means they are responding to acetylcholine. And anytime acetylcholine binds to them, they are going to trigger a change in the protein and a change in the cell, okay? But your nicotinic receptors can also respond to nicotine, which is that drug that is in like cigarettes or in vapes. It can be very addictive, and it has a lot of different effects on our body. So these receptors are not necessarily meant for nicotine. They're meant for acetylcholine, but some drugs can have an effect on those receptors as well, in addition to acetylcholine. Here we have muscarine or muscarine, and I looked it up, and it's actually a toxic chemical in some mushrooms. So that, once again, these are not necessarily intended for these chemicals, but these chemicals are able to bind and trigger a change. And so we're going to first take a look at nicotinic receptors. They are ligand-gated ion channels. Now, we've actually already seen this. In muscle contraction, acetylcholine would move across the synapse. It would bind to the receptors. Those receptors were nicotinic receptors. And what happened when that acetylcholine would bind to them is it would open up a channel. Okay, so this is always going to have an excitatory effect, and what's going to happen is sodium channels are going to be opened. Sodium is going to rush into the cells, and it's going to trigger an action potential. So that's the way your nicotinic receptors work. Okay, so the acetylcholine binds to them. It essentially opens up that ion channel, and then sodium is going to flow in, triggering an action potential. Okay, so these are the ones that are going to be between your pre- and postganglionic neurons. Remember, all of your preganglionic neurons were secreting acetylcholine, and so all of your postganglionic neurons are going to have these nicotinic receptors, okay? All of your skeletal muscles are also going to have these nicotinic receptors, okay? So they're always responding to acetylcholine. Those sodium channels are going to open and action potentials are going to be triggered. So you can see over here in the picture, all of my preganglionic are secreting acetylcholine. All of my postganglionic were nicotinic receptors, okay? All right, now your muscarinic receptors, these are going to be found on all parasympathetic effectors. So in your parasympathetic postganglionic neurons, they are going to be releasing acetylcholine, and that acetylcholine will be binding to these muscarinic receptors, okay, in the parasympathetic division. Now, they're actually not ligand-gated ion channels. You don't have to know the specifics here, but they're actually called a G-protein linked receptor. And what happens is when acetylcholine binds, it's actually going to activate enzymes. okay? Or it could regulate gene expression. And so just know it's a different kind of response. But in this case, we still have ACH binding, but it could be excitatory or inhibitory. So in some organs, like in the case of cardiac muscle, it's going to reduce heart rate. Remember, the parasympathetic has different effects on different effectors. And so when the acetylcholine binds to smooth muscle, remember, it stimulates the digestive system. So that's why it could be excitatory or inhibitory. Okay, so once again, this is in the parasympathetic system, and this is going to be on all of those effector cells. So it's not the same as a sodium-gated ion channel like we saw in the nicotinic. They're going to have different responses. All right, our next type are your adrenergic receptors, and as we mentioned earlier, they're going to bind to either norepinephrine or epinephrine. Now, these are going to be in the effectors of the sympathetic division. Remember, the sympathetic is your fight or flight. So the only ones that we really need to respond to stress, adrenaline, epinephrine, is going to be those effectors in that sympathetic division. So the nervous system can stimulate this. It can also trigger the release of those chemicals from the adrenal gland. And there's two types. There's alpha receptors and there's beta receptors. You really don't have to know much more than that. But just know that these are binding epinephrine or norepinephrine, and they're going to be in your sympathetic effectors. So there must not be a huge amount of alpha 3, because every picture that I found only had alpha 1 and alpha 2. And you can just kind of see the differences here. So these are all just adrenergic receptors. They're going to be on different cells and trigger those responses. All right, so as a summary, once again, all preganglionic fibers release acetylcholine. So all preganglionic neurons are cholinergic. All ganglionic neurons, which are going to be the ones that are in that ganglia, okay, they have nicotinic receptors. So your postganglionic cell bodies, they're all going to have those nicotinic receptors because all preganglionic were releasing acetylcholine. These are the ones that were ligand-gated ion channels, so they're going to trigger depolarization and action potentials. Your postganglionic parasympathetic are going to release acetylcholine to muscarinic receptors, and most of your postganglionic sympathetic are releasing norepinephrine, which bind to the adrenergic. And then here's another kind of effects of your parasympathetic and your sympathetic, but they also included the type of receptors that you're dealing with. Okay, this is going to be the receptors that you'll find in those particular organs. So you can see that all of these are your adrenergic receptors. So these are going to be your effector cells, and these are going to be your sympathetic. And then over here, we have the parasympathetic. You have your M's. Okay, all of those are going to be muscarinic. And so there we go. Okay, so it also kind of shows you what's happening. This is similar to what we talked about earlier, like heart rate increases or heart rate decreases. We release epinephrine or we aren't affected at all. We decrease salivation or we increase salivation. All right, so this is similar to what we looked at before. And the last slide is just going to be some generalizations. Okay, now remember, there can always be exceptions to the rule, but these are just some overall general characteristics of both the sympathetic and the parasympathetic. So both can be excitatory or inhibitory. Most organs are affected by both. They typically produce opposite effects. Typically, sympathetic is preparing us for physical activity in that fight or flight, whereas parasympathetic is preparing us for rest and digest. And that's going to be the end of chapter 15. So I've posted some videos for you. Hopefully these can be helpful. There's also some diagrams in your handouts that go along with this video here if you'd like to fill those out. And then don't forget, you have your last and final lecture test coming up. Be sure you pay attention to due dates. You can use a note card for this one. It has to be handwritten only, front and back. You cannot tape anything on or type and paste anything on. And as always, if you need help, get it. And good luck to you guys. And we are officially done with notes for A&P1. Congratulations, you made it.